Let's do a few more examples of solving for missing sides and angles in triangles. So in this one, we know one side and one angle. Right? So we're not going to be using Pythagorean theorem. Right? We're not going to be using inverse trig because we know an angle. Right? So if we know one side, we're going to be solving for the other sides with trig ratios. If we know one angle besides the 90-degree angle, we're going to be solving for that missing angle using triangle sum theorem. So let's get started. All right, and we're going to work with our angle that we're given. Let's solve for side A first. We'll go alphabetical. Side A is opposite angle A. The known side B is adjacent. Who's opposite and adjacent? Well, of course, that's tangent. All right, so let's first of all solve for side A. Right, and we have tangent 41 equals A divided by 17. Right, we need to isolate A, and that's as simple as multiplying both sides by 17. So 17 times tangent 41 equals A divided by 17 times 17. The 17's cancel. So we have 17 tangent 41 equals A. And now we'll plug that into a calculator to find our answer. Look how fast we're getting. We can do them now in just like a minute. All right, so there's our calculator. We need, let me clear that, let me get rid of that. So we have 41 tangent, all right, there's our tangent ratio, and we multiply that times 17. All right, so 14.77, I'll round to 3 decimals this time, 14.778. All right, so now let's solve for the other side. So we're going to solve for C. That's our other missing side. I guess it's enough space. I have a lot of space over here. I don't think I need to cram. So you know what? I'm going to move this over just a little bit. All right, so step 2 will be solve for C. All right, so C is, of course, opposite the right angle. It's the hypotenuse. Now we won't use A, right, because I rounded. I remember I said let's round to 3 decimal places. We'll use B, right, because B is a side we know. We know the adjacent. We're looking for the hypotenuse. Who uses adjacent and hypotenuse? Well, of course, that's cosine. So we have cosine 41. Right, we always write the trig ratio, then the angle, and then equals our ratio. So the ratio is the adjacent side, which is 17, over the hypotenuse, which is C. We need to get C out of the denominator, so we'll multiply both sides by C. So we have C cosine 41 equals 17 times divided by C times C. The C's will cancel. So now we have C cosine 41 equals 17. But we're not done solving. All right, we're not done isolating. We have to divide both sides by cosine 41 to isolate C. So C is equal to 17 divided by cosine 41. Let's plug that into a calculator and find out how much C is. Right, so we have 17 divided by parentheses. I have to hit 41 first, and then the cosine. Close my parentheses, so I divide by all of cosine 41, and we get 22.525. And we're expecting a number larger than 17, right, because this is the hypotenuse. This has to be the largest side in the triangle. So 22.525? 525. Right, so lastly now let's solve for angle B. And there's no reason to use an inverse trig ratio. First of all, we would have rounding error because these are sides we solved for, and that'll create some rounding error. But we can always just use triangle sum theorem, and that doesn't create any angle error at all because there's a limit to the sum of the angles in a triangle, and that's 180. So angle B is equal to 180 minus 90 plus 41, which means angle B is equal to 180 minus 131, or 69 degrees. And that's it. Look at that. 5 minutes, we have found 2 sides and an angle. Not bad. I have 3 more problems like this. Let's see how long it takes us. All right, so this is one more where we're solving for missing sides and angles. This time we do know one of the angles, so we will not be using inverse trig ratios. So now you can see why on that previous video I used inverse trig ratios twice to get the practice. All right, so we need to solve for the 2 sides in the triangle. The side we know is the hypotenuse. I guess we can solve alphabetically, so we'll solve for x. Relative to angle A, x is the adjacent side. Who uses adjacent and hypotenuse? Of course, that is cosine. So first thing we're going to do is let's solve for x. All right, so we have cosine 50 equals, the adjacent side is what we're looking for, the hypotenuse we know. Multiply both sides by 8.3 to isolate the variable. Those will cancel, so we have 8.3 times cosine 50 equals x. We've got our variable isolated. It was as simple as setting up the equation and multiplying both sides by 8.3, by the denominator. So now we can just plug that into the calculator. And by the way, you can use the table. You would just replace cosine 50 with the decimal value for the trig ratio value for a cosine of a 50-degree angle. The calculator has the same thing in its memory. So either way, we're really doing the same thing. So we have 50 cosine, right? Because we would have that value in the table. It would just be rounded to 4 decimal places. And we'll take that and we'll multiply times 8.3. And we'll round to 3 decimal places again. So we have 5.335. All right, so now let's solve for y. All right, so y is relative to the angle we know, the opposite side. It's across the triangle. Who uses opposite and hypotenuse? The side we know, well, of course, it's sine. So we start with our trig function, sine of our angle, 50, equals, and for sine, it's the opposite side, which is y, over the hypotenuse, which is 8.3. The steps on this one is going to be exactly the same as the other one. We're going to multiply both sides by 8.3. That'll cancel. So we have 8.3 sine 50 equals y, and we'll just plug that into the calculator, and we'll get y. Right, so I have 50 sine times 8.3. And we get 6.358. And there we go, we found it. So the trig table is just those values that are in the calculator, but they're rounded to they're just for whole value integer value decimals in the table, and they're rounded to 4 decimal places. That's the only thing that's different. All right, so now we want to find the missing angle. Let's use triangle sum theorem because we already know 2 angles in the triangle. So we're solving for angle C. That says 4. All right, so angle C is going to be equal to 180 minus the other 2 angles in the triangle, which is 90 plus 50. That means angle C is 180 minus 140, or 40 degrees. All right, not too difficult, right, to figure out that missing angle. And another triangle has been solved. I think I've got two more. And these are the trickiest ones of all because they're not going to have a triangle labeled at all. All right, and I have the steps here, and I don't know if they're in your notes, but you can always do a little screenshot and print them out so you have them. So we're going to need a triangle to organize it, our information, because we don't have a triangle, right? And so all you have to do is, as your very first step, is draw a right triangle and mark the right angle. So I just used the drawing tool on here to draw a triangle, and I've now marked the right angle. So now I have a right triangle, right? And we're going to, and by the way, in all of our examples, C is going to always be the hypotenuse. If you don't know who the hypotenuse is, it's going to be really hard for you to label. So in every example, C is the hypotenuse. And in your homework, it'll say C is the hypotenuse. It said it here, but I cut that part off because I just wanted the problem. So C is opposite the right angle. It is the hypotenuse. So the hypotenuse is 3.45. Because it's important where we label the hypotenuse. There's only one hypotenuse in the triangle. It doesn't matter where I label the other sides, right, relative to that, right, because this doesn't have to be drawn to scale, right, but I do need the hypotenuse in the right spot. So 3.45 is the hypotenuse. That is opposite angle C because this the hypotenuse is side C. One of the other angles is angle A and angle B. And how do we know there's an angle A? Because all of them were angle A, B, and C. I wasn't very unique here. So let's look at our set of steps. We have drawn the right triangle, and we've marked the right angle. We labeled the right angle first. That's going to be angle C. The hypotenuse is going to be side C. Now you can label the acute angles A and B. And it doesn't matter who's A and who's B, but once you've labeled angle A, the side opposite that will be side A. And once you've labeled angle B, the side opposite that will be side B. All right? If you know an angle, label opposite, adjacent, and hypotenuse. We do know one angle. Of course, hypotenuse is always going to be opposite the right angle. That's not dependent on whether or not we know an angle. All right, so we do know one angle measure, 17.8 degrees. Now, how do we know that's an angle and not a side? It's capital. All right, so capital letters mean sides, lowercase letters mean, capital letters mean angles, lowercase letters mean sides. So this is an angle B, this is side C. All right, so capital is an angle, lowercase is a side. All right, so now we want to solve for all of our missing information. And it might get a little crammed here because I didn't give myself much space, but we'll do our best. All right, so we know one side and one angle. All right, the easiest thing to do is to find the other angle. Let's just find the other angle because I have a little bit, I think I have enough space right here between this one and the other problem. All right, so we want to solve for angle A. That's the one we're missing. Actually, let me check something. I'm going to make sure that I don't have the same problem on the other page and I could just cover it up. I do have the same problem on the other page. I'm going to give us some more space. It's the magic of the smartboard. I'm going to now properties, and we're just going to fill it up with whiteness. Oops, solid fill and white. Oops. Cancel. I don't think I got the okay, now it's good. There we go. Now I've got it. It's a white box blocking. And now we have plenty of space. But we can just solve for angle A because that's really, really easy. All right, so remember, we can just use triangle sum theorem when we know two of the angles in a triangle. So angle A is just going to be 180 degrees minus 90 plus 17.8. So that means angle A is 180 minus 107.8. So that's going to be 72.2 degrees. That looks a little too much like a 2, doesn't it? 72.2 degrees. There we go. And that's all there was to solve for the angle. Now let's solve for one of our sides. It doesn't matter which one. I guess let's start with, go alphabetical. We'll start with side A. Now we want to stick with the angle we were given, angle B. Relative to angle B, side A is the adjacent side. And of course 3.5 is the hypotenuse. What trig ratio uses adjacent and hypotenuse? Well, of course, it's cosine. All right, so we're going to solve for A. That's step 2 here. And so we have cosine 17.8, that's our angle of reference, equals A, the adjacent side, over 3.45, the hypotenuse. We're going to multiply both sides by 3.45. All right, so that will cancel out here. So we have 3.45 equals cosine 17.8. And, oops, we lost something there. Yes, sorry. 3.45 times cosine 17.8 equals A. All right, so we'll plug that into a calculator and find out what A is. All right, so we have 17.8 cosine, and then multiply that times 3.45. So that is, we're round to 3 decimal places, 3.285. All right, and now let's solve for the other missing side. Solve for B. All right, so relative to the angle we know, angle B, side B is the opposite side. So we're looking for the opposite. We know the hypotenuse. Who uses opposite and hypotenuse? Well, of course, that's sine. So sine 17.8 equals B divided by 3.45. And it's pretty easy when you're looking for the opposite or adjacent side and you know the hypotenuse. You just have to multiply both sides by the hypotenuse. And when you do, B is isolated, your variable is isolated. So 3.45 times sine 17.8 equals B. All right, so now this, by the way, is an example of a problem where the table wouldn't work so well. Because 17.8 is not an integer value, it's not in the table. So here we would really have to use a calculator. What would you do if you didn't have a calculator? I would round 17.8 up to 18. You're going to have a little rounding error, but it's okay. Especially if you tell me that's what you did and I know that in advance. All right, so now let's just plug this into a calculator. So we have 17.8 sine. Right, there's our sine ratio. And then we're going to multiply that times 3.45. And we get 1.05. We'll round to 3. 1.055. And there we go. This one is done. We found all of our sides. We found our missing angle. We're going to do one more. And this one is in your notes as well as the other one was. There's the same set of steps. This one, I have a triangle drawn out for us. But all you're going to do when you're doing this problem in your homework or in your notes, you're just going to draw yourself a random triangle. It's not drawn to scale. It's just a triangle to organize your information. You're going to mark the right angle. This is always angle C in our problems, right? So that's angle C. You have two other angles in the triangle, angle A and angle B. It doesn't matter who's angle A and who's angle B. It's just that they're not the right angles. All right, now you're going to label your sides. All right, so opposite angle C is side C. Side C here is, of course, has to be the hypotenuse because it's opposite the right angle. Who's opposite and who's adjacent depends on your point of which angle you're working with. But opposite angle A is side A, and side A is 6. You don't have to put 6.00. Opposite angle B is side B, and side B is 8.46. So we have two sides in a right triangle, and we're looking for the third. What are we going to do? We're going to use Pythagorean theorem. So you're going to use Pythagorean theorem to find C. All right, so, and we are not going to simplify this radical because we're going to end up with a decimal on the radical. If we end up with a decimal, we'll take a decimal approximation. So C squared is equal to the other two sides, the sum of the other two sides squared. So 6 squared plus 8.46 squared. 6 squared is 36. I don't know what 8.46 squared is, but I have a calculator. A very cheap one, though. Doesn't even have a square on it. All right, so that's going to be 71.5716. All right, we'll add those together. So that's 107.5716. This is not something we can simplify. So we are going to take a decimal equivalent. It's the only time is sometimes with a real world problem, and always if you have a decimal as part of your radical there. So I'll round it to 4 decimal places. So 10.3717. Now we would never calculate with that value because that was rounded, right? So that would introduce rounding error. All right, so we have found our missing side. Now we're going to find our missing angles, and we're going to use inverse trig ratio. And we're finding, let's find angle A first, I guess. So relative to angle A, 6 is the opposite, and 8.46 is the adjacent. So we always start with our trig ratio. What trig function deals with opposite and adjacent? Of course, that's tangent. So we have tangent A equals, the opposite is 6, the adjacent is 8.46. To isolate A, we take an arctan of both sides. Arctan and tangent cancel, so that's A equals arctan of 6 divided by 8.46. And we are going to plug that into a calculator. Oops. And there's my calculator. So I have 6 divided by 8.46. And that equals, right? And then we're going to do, so that's the ratio. And now we want to find whose angle has that ratio. So I need arctan, not tangent. And that is a 35.35 degree angle. Now at this point, you can either use a trig ratio again, or you can use triangle sum theorem. All right, since we did several examples where we did both of the angles with the inverse trig ratio, and it would just be tangent again, opposite and adjacent would just switch. Let's just use triangle sum theorem to find our missing angle. To find angle B. So angle B equals 180 degrees minus 90 plus 35.35. That would be 180 minus 125.35. And so that's going to be 54.65. And let's just check, make sure. Okay, that would be 1. Okay. Yes, I think that is correct. All right. All right, so we have finished finding all of our angle measures and side measures. For the solve a triangle where I don't give you a triangle, it's going to be one of two things. You're going to know two sides, like this one. You'll use Pythagorean theorem to find the third side. You'll use an inverse trig ratio with the sides you're given to find a missing angle, and then you can use triangle sum theorem to find the other angle. It's exactly like this. Or it's exactly like this problem. All right, so here we solved for our missing angle. We only had one missing angle, and we used triangle sum theorem. No reason to use, matter of fact, you couldn't use a inverse trig ratio if you're missing, if you only have one side. All right, so we solve for angle A using triangle sum theorem, and then you'll solve for both of your missing sides using a trig ratio. Which one depends on what you know and what you are looking for. Oops, okay, it can't be a capital B. I was trying to fix my lowercase b using a trig ratio. There, now I'm more specific. You can add that to your notes, on my notes. And those are the only two examples. Either you know two sides or you know a side and an angle. Right? Otherwise, you wouldn't be able to solve. So that's the end of this video. Thanks for watching. If you have any questions, let me know. And this is very much like two problems in your homework. And it's the trig word problem homework. It's the next homework. And actually, in the next series of lessons, we're going to learn how to solve real-world problems using trig ratios. So thanks for watching, and bye for now.